Because we'll be using technology to solve the linear programming problems for this section, the important skill that we want to practice is constructing the constraints and objective function from word problems. Let's consider the following problem. Your company is creating a new recipe for a protein bar. Each batch calls for between 400 and 600 grams of flour, of which at least 100 grams must be almond. The total grams of protein per batch should exceed 160, and fat should not exceed 75. How much of each flour should be used to minimize cost? We're also given the following table that gives nutritional information for each kind of flour. Almond flour provides 21 grams of protein, 50 grams of fat, and costs $1.70 for every 100 grams. Chickpea provides 22 grams of protein, 7 grams of fat, and costs $1.20 for every 100 grams of it. Lastly, we have sunflower seed, which provides 48 grams of protein, 2 grams of fat, and costs $3.57 for every 100 grams. Here are variables, the things we're trying to choose, is how much of each almond, chickpea, and sunflower seed we should use. I'm going to construct A, C, and S, and they'll represent the number of 100 grams of almond flour used. And similarly for C, the number of 100 grams of chickpea flour, and the same for sunflower. I do this so that I can use the same numbers provided in our table for protein, fat, and cost. To construct our constraints, let's look at what our problem tells us. The first sentence doesn't provide us anything we can use as a constraint. However, the next sentence, that each batch calls for between 400 and 600 grams of flour, tells us two things. First, it tells us what it needs to be at least. It needs to be at least 400, and it tells us what it has to be at most, 600. That means it gives us two inequalities. The first inequality being what it's less than or equal to, and since each 1A contains 100 grams of flour, each C contains 100, S is 100, we'll have less than or equal to 6 rather than 600. Similarly, we'll have A plus C plus S is greater than or equal to 4 as our second inequality. Continuing in that previous sentence, we see that we also require that at least 100 grams come from the almond flour. This tells us the amount of almond we use, and since our variable is measuring number of 100 grams of almond, it must be greater than or equal to 1. Next, we see some constraint that's talking about protein. The total grams of protein per batch should exceed 160 grams. A statement about exceeding is a statement about greater than or equal to. And we want greater than or equal to 160 grams of protein. We know that for every 100 grams of almond, we contribute 21 grams of protein. For every 100 grams of chickpea, there is 22 grams of protein. And for every 100 grams of sunflower, there's 48 grams of protein, giving us the inequality 21A plus 22C plus 48S is greater than or equal to 160. Our last inequality is the amount of fat in the batch from flour should not exceed 75. Following the similar step for what we did for protein, but using our table for fat each flour provides, we get the equation 50A plus 7C plus 2S should be less than or equal to 75. We still haven't used all of the information in the problem, and we still haven't identified our objective function. Here, the remaining information in the problem will be about the objective function. It asks us a statement about how much flour should be used to minimize cost. The keyword minimize clues us in that that's going to be dealing with our objective function. And to construct our cost function, we'll use that information provided in our table, namely that our objective function will be 1.7 times A plus 1.2 times C plus 3.57 times S. Because this is a real-world problem, we can deduce that all of our variables must be greater than or equal to 0. At this point, we've identified enough information for us to turn to technology to find our optimal value.